Hi everyone. So in this video, we're going to work through a year 12 question on exponential modeling with a little bit of logs. And this question is from the AS sample paper. So we have here a town's population P, and this population is modeled by the equation P equals AB to the power of T. A and B are constants. T is the number of years. I'm going to underline that because units with these questions are sometimes important. The number of years since the population was first recorded. So this is an exponential model because the variable T is in the power. So just be aware of that. That's an exponential model. So we've got the line L shown in figure 2, and this illustrates the linear relationship between time and log base 10 of the population for the population over a period of 100 years. So we've got that the line L meets the vertical y-axis at the point 0, 5 as shown on the diagram. The gradient is 1 over 200. Write down an equation for the line. Okay, so this is obviously a straight line. So this is going to be a y equals mx plus c graph, of course. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams have finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018, and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams, and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up to the app, and you'll be able to access all of these 2027 predictions. Now, we know the gradient is m. So let's just write this down here. So for part A, the gradient is m, and we're told the gradient in the question is 1 over 200. So that's quite obvious. Now, the y-intercept of the graph is clearly c plus c, and in this case, it's 5 there. So the plus c is 5. Now, the y is the y-axis variable, and the y-axis variable here is log base 10 of p, and the x-axis, the x variable, is time. So therefore, that means if we write down here, the equation of L is going to be, let me just rub out this line here, is going to be log base 10 p equal to the gradient 1 over 200, and then the x variable t plus the y-intercept of 5, and that's our equation for the line. If you wrote down y equals 1 over 200 x plus 5, you would lose a mark because the variables on the y-axis are log base 10p and the variable on the x-axis is t. So make sure you get your variables correct. So that's part A done. Now for part B, find the value of A and the value of B. Okay, so with this question, we know that we've got an exponential model, P equals AB to the power of T. So really what we want to do with this is somehow convert this equation, log base 10p equal to 1 over 200 t plus 5, into the form population equals AB to the power of T, or the other way around. We could do it the other way around. And in fact, actually, that's what I'm going to do with this question. I'm going to start with the exponential model. So start with P equal to, so I forgot to write down the width there, P equal to AB to the power of T. And then I'm going to take a log base 10 on both sides, because clearly on the left-hand side of the line L, there's a log base 10. So it just makes sense to take a log base 10 on both sides, like so. Log base 10 a b to the power of t, like that. Perfect. Now, using our rules of logarithms, the addition rule, when you add logs, you multiply the inside. So we have here log base 10a plus log base 10b to the power of t, because we have here a times b to the power of t. And then the power rule of logs tells us that if there is a power inside a logarithm function, you can bring that power to the front. So this gives us log base 10a and then plus t multiplied by log base 10b there. Perfect. So if we compare this equation that we've created here, I mean, let's call this equation 1. If we compare equation 1 to the equation of line L up here, obviously on the left-hand sides, we've got log base 10p. That's fine. So we got that there. Then we've got a 1 over 200t. The t is there. So that means that therefore log base 10 of b has to be 1 over 200, because this line is the same as line L. The line L has to match this equation 1 that we've created. So the coefficient of t, 1 over 200, is equal to log base 10 of b. And the y-intercept is clearly 5. So therefore this constant must be 5. So you've got two equations here. So therefore log base 5a is equal to 5. Sorry, not base 5. I've made a mistake there. Let me rub that out. Log base 10 of a is equal to 5. So therefore, hopefully you know that that means that a is equal to 10 to the power of 5. So this would be 1 and 5 zeros, 0, 0, 0, 0, 0, so 100,000. And then with the second equation, log base 10 of b is 1 over 200. So therefore, b is equal to 10 to the power of 1 over 200. Now, I'm just going to scroll up and just see if we needed a and b to any sig figs. It just says find the value of a and value of b. Okay, what I'm going to do in that case then, I'm just going to leave my answers like this in exact form. So I'm going to leave that there and that there. You could work out this value 10 to the power of 1 over 200 if they wanted it to 3 sig figs. I'll just do that now on my calculator. So this is 1.01 to 3 sig figs. So you could say that 3 sig figs b is equal to 1.01 if you wanted to. And that would be fine as well, because they don't specify how many sig figs, or they don't specify that they have to be exact values. I'm just going to check again and just make sure they don't. No, they don't specify a and b must be exact. So in a question like this, you can either leave the answer in exact form, or you can round to 3 or 4 or 5 sig figs. Don't round to less than 3 sig figs. Don't round to 1 or 2 sig figs. 3 is normally fine for a question like this. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Perfect. So now let's move on to part C. So with reference to the model, interpret the value of A. I've kind of run out of room down here. Yeah, so I'm going to try and fit in my answers here. So for part C, interpreting the value of A. So with a model, an exponential model like this, so P equals A times B to the power of T, imagine if T was 0. So if T was 0, you would have A times B to the power 0. B to the power of 0 is 1. A times 1 is A. So therefore, A is the initial population for this model specifically. It's the initial population. And when did we start measuring? It just says that T is the number of years since the population was first recorded. So what we'll just say is A is the initial population once recording begins. Once recording begins. Perfect. So I've not spelled that correctly. Let me write that again. When recording begins. There we go. Now for part II, with reference to the model, interpret the value of the constant B. Okay, so a lot of students get this wrong. They make mistakes with a question like this. Do not say that B is the rate of change. I see that a lot with students. A lot of students will say that B represents the rate of change. No, no, no. The rate of change of the population is what you get when you differentiate the model. B is not the derivative of the model. So therefore, B is not the rate of change. What you can say instead is you can say that B represents the factor of population change per year. So again, with this question, T is measured in years. And as we can see down here, when we worked out B was about 1.01. So that represents roughly about a 1% increase per year. Now, that's not the rate of change. It's just a factor of increase. So what you can say is B, let's just write this down here for part II. So B is a factor that represents the change in population per year. Now, alternatively, you could actually say for your answer with a question like this, that this represents a 1% increase per year. So you could also say that as well. Let me just cross that out there and write this down here. So you could say that B represents a 1% increase in population per year. It's very important that you state the units of the question. So this is a population change per year. Per year. Fantastic. Great. So that's part C done. Now with part D, the population predicted, or find the population predicted by the model when T is 100, giving your answer to the nearest 1000. Okay, I'm going to try my best and fit this in here. So the population when T is 1000, so we know from our formula that A was 100,000, as we found down there. So the population will be A 100,000 multiplied by this value of 10 to the power of 1 over 200. I'll use the exact form here. So B, which is 10 to the power of 1 over 200, and then to the power of 100, because T here is 100. And what I will do is I'll just work out the, oops, nearly dropped my calculator there. I'll work out this value on the calculator. So 10 to the power of 1 over 200. And then to the power of 100. That's basically the square root of 10, isn't it? I should have just put in the square root of 10 in my calculator, would have saved me time. Times by 100,000. So this is 316,227 roughly. We want the answer to the nearest 100,000. So to the nearest 100,000, this is 300,000 to the nearest 100,000. So 300,000 to the nearest 100,000. Perfect, great. So that's part D, part I. Now for part II, find the number of years it takes the population to reach 200,000 according to the model. So with this one, we will do this over here. If we can squeeze this in here. So we've got 200,000 is equal to A again, which is 100,000, 100,000 times by 10 to the power of 1 over 200 to the power of T. So that's just basically going to be T over 200. So we can divide both sides by the 100,000. So that leads us to t, or 2, sorry, not t. 2 is equal to 10 to the power of t over 200. And then what we can do now to bring the power down is we can use log base 10 on both sides. So hopefully you'll be happy with the idea that now this means log with a base of 10 of 2 must be equal to t over 200. So therefore, if we multiply by the 200, that will give us the time. So if we do log base 10 of 2 and then times by 200, this gives me about 60.2 years to 3 sig fig. So I'm going to just say here 60.2 years to 3 sig figs. I'm going to just try and fit this in here. Sorry, I know this video has been a bit messy today, but hopefully you've been able to follow along. Now, there's just one more part of the question here. So state 2 reasons why this model may not be realistic or may not be a realistic population model. Well, let's think about what's happening with this population model. This is an exponential model and the population is always increasing. And it's always increasing about 1% per year. So I think firstly, what I would say is that it's unlikely that the population is going to increase by a constant factor of 1% per year. So I will write that down for part D as my first reason. Let's try and fit this in down here if we can, part E. So my reason 1 is it's not realistic that population always increases at the same factor b equals 1.01, which is a 1% increase per year, factor per year. So we can say that this factor is likely to change per year. So that's one reason you could say. And you could also talk about the idea that populations can decrease. So if there's some kind of war or disease, that could decrease the population. So we can say here that as a second reason, or reason 2, the population could decrease due to illness or war. And the model doesn't account for this. Model doesn't account for this. Because it only accounts for the population increasing, or if the b was less than 1, if it was between 0 and 1, that would be a decreasing population. But this model doesn't account for populations increasing and decreasing in different years. Okay, it's not for example, like a sine wave or a cos wave where your population will be increasing, decreases. It's not like that. Doesn't account for any kind of increase or decrease, either an increase or a decrease always. So I would say those were my 2 reasons. But if you do have any questions on this example that we've worked through today, do drop a comment below and I will get back to you if you do need anything. But hopefully all of that has made sense.